Okay, so good afternoon, class, and welcome back to Science 10. Yesterday we were looking at definitions of ecosystems, examples of them, and looking at the diversity of life, biodiversity of living things. And we've seen that most of the land forms, where do most of the terrestrial things live, the different kinds of species? Most of them live in tropical forests. Okay, if we went to the rainforest in the Amazon, we'll see more different types of species of animals and plants than any place in the world. And for the oceans, where's the biggest biodiversity in oceans? It would be in the Western Pacific. Western Pacific. There are hot spots all over the world, but we're looking at where the greatest ones were. So we looked at biodiversity yesterday, and we looked at examples of ecosystems. So today, we're going to just focus in a bit on the energy that's in ecosystems and how it gets transferred. Because energy cannot be created or destroyed. It can only be changed, moved around. So once we've done that, you'll have your assignment 5 in your pickup box. So let's just look at a few examples here. Now, question, have any of you ever seen the moon when the sun was rising? It means in the morning, before it gets completely light. Sometimes you can see the moon in the sky. Does it look any different or anything about it you might have noticed about it in the morning? Usually when you look at the moon at night, it's just kind of a white light, right? Because you got all that blackness behind it, around it, and the stars. The stars kind of make it brighter too because you have all of those sprinkling of stars around it. But in the morning, because you can't see the stars anymore because the sun is getting so bright, when you still see the moon, you start seeing features of the moon, some little gray areas. You're starting to see what really the surface of the moon it looks like. So here's a couple little pictures. Here the sun is just rising, and you can you see the moon, and you see those little orange. That's what the surface of the moon. We start seeing the relief, seeing what the surface of the moon looks like. And here you can see it again. It's a little different blue color than the white around it. So we're seeing parts of the moon that usually you don't see at nighttime. And why is that? Well, there's a reason for that. And that's what we're going to look at today. Here's the other thing. Have any of you ever seen satellites orbiting the Earth? We know that there's a space station up there, International Space Station, that's going around the Earth. Has anybody ever noticed that in the sky? What's different about it than the stars? How do you know when you're looking at that satellite? It's moving. That's right. Stars don't move, but when you look it up, and it looks like a star, but it's moving. So this is what the satellite looks like if you're up in space. Okay, it probably has these solar panels. Solar panels here. That's where they get the energy for this thing to operate. There's another one over there. But if you were down on Earth looking up, you might only see this thing right here. Just a white, like a streak going across the sky. It's moving. Okay? It'd either be a dot that's moving, or it almost look like a shooting star sometimes. So that's what satellites will look like if they're orbiting the Earth. Now, here's some little questions, and we'll have a little flash thing here. Why do we see the moon? Where does the light come from? Where does all the light come from on Earth and up in the sky? The sun, right. So it's the sun that reflects it, So I don't know if this is going to flip or not. Oh, I won't do it here. But why do we see the moon? It's because it's reflective light. It's because this isn't installed on here. I'm sorry about that. Does the moon and the satellite produce light of their own? Well, the moon doesn't have a generator. The moon doesn't produce light. Satellites, it's the light is reflecting. It's reflecting light from the sun. Reflecting. And why can the moon be seen during light hours? It's because we're still looking at a reflection of the moon. And it's just at that point where the sun isn't strong enough. The light is not so strong that it makes everything else look too light. We can't see it anymore. It's too bright. Can satellites be seen during daylight hours? Generally, they might. It might look like if you have a good telescope, you might see like a dot going across the sky. Generally, you don't see it too well. They're they're pretty big. I mean, they're big enough for them to keep food in there and to sleep in there and move around. And usually there's, could be 4 or 5 people sometimes. So, and they got a big robot arm there, Canada arm on it. It's probably as big as maybe this TC Center here, okay? And but because it's so far away, it's so hard to see. Okay. So what determines the amount of sunlight that's reflected by an object? Well, why do when we see things on a pond on a very, very calm day, when it's not windy, you can see a reflection, right? Why is it better to see it then than when the wind is blowing? What's different about the surface of the water? When the wind is blowing, it has ripples, but when it's not, it is smooth, right? So the smoother the object, the more the reflection. It's as simple as that. So that's why we can see things like the moon, because it's being reflected. Now, it's not smooth, but it's so big that it does reflect a lot of light from the sun. Now, if people launched a satellite as large as the moon, would it be brightness compared to that of the moon? Well, if it was a satellite, satellites have metal surfaces. Metal is usually smooth. And if it was as big as the moon, it'd probably be brighter than the moon, because the moon has bumps on it, has mountains, has craters. So the satellite would be a lot brighter. Now, is all of the light that shines on a surface reflected? All the light? Well, it's not. Some of it is reflected, but some of it is absorbed. Some of it is kept into the ground. That's why you wear light clothes in the summertime, because you don't want to get hot. The light reflects off of it. But if you wear dark clothes like a sweater in the hot sun, you'll find you get hot quick because it's absorbing that heat. Good afternoon. So this is what really controls the amount, or how we measure the amount of reflection. It's called the albedo effect. Albedo is a measurement of the amount of light that an object reflects. So something like a mirror has a very high percentage of albedo. It means that it'll probably be getting close to 100%. While something like your dark sweater has a very low percent because it won't reflect much light. Okay. Also, what affects it is how high, I mean the percentage, how big a reflection it is, but it depends on how big it is, the diameter and the distance from this. So stars are so far away, we can just see the little pinpoint of their light, but the closer things get to our Earth, close to us, the brighter it seems. It's like anything else, just like if you're going down the road. You might see a car in the distance, just like a speck, a little shiny thing, but as it gets closer, it gets brighter and brighter. So the distance is a big effect too. And does all the energy striking the Earth in the form of light? Well, no, because there's something else besides the light that comes from the sun. It's the heat. We have thermal energy. Okay, so some of that energy that comes to the Earth from the sun is also thermal energy, heat energy. What would you rather use on an outdoor swimming pool? Deck, the deck around it, would you use black or white paint? Black. You know what happens if you have black paint? You get out of the pool, your feet would burn. Okay, because the black would absorb the heat. You want white, so it would reflect it. Especially if you don't want to be in the water all the time. If you want a suntan, you want to sit in your chair. Can you imagine you're sitting on your chair and then you won't get up to go get a drink, and as soon as you put your feet on the black deck, you'll be burning the soles of your feet because it gets so hot. So you want to get a white deck. What happens to light energy that is not reflected from the surface? Well, if it's not being reflected, it means it's being absorbed. It's being kept there, and it's usually being changed into heat, into thermal energy. Okay? It cannot be lost. It just changes its form. If you take a magnifying glass, right? If you ever did that when you were a kid, and then you shine it onto an object, so it's just a pinpoint, That's just light. But what happens if that light is focused on one point? It burns, it heats up. So that's what happens to light. If it's not being reflected, it is changed into heat energy and becomes thermal energy, hot. So, where does all this energy come from in our ecosystem, where we live, where everything lives? Well, it comes from the sun. Okay, that's the ultimate source. The ultimate source. So, it also gives us light in the daytime when our Earth is turned so that it faces the sun. It gives us light so we can see where we're going, and also warms. It also will evaporate water. All that oceans and stuff, it evaporates it. The water goes up into the air, forms clouds, and then it released back to the earth as rain and gives us water, not salt water anymore, but fresh water that we can drink because we need water to live. So it forms rain and snow. It's used by plants. Now, plants is the only living thing that can take light directly from the sun and make food out of it. We can't do that. We have to eat the plants to make food. We have to eat meat, which eats plants. But the ultimate source is plants that can make food from light. So they're the ones that can only make food from light, is plants. And they provide food for all the other organisms. Only 1 billionth. That's a very small number. That's 1 over. That's a million. That's a billion. Okay? 1 of 1 billionth of that energy comes from the sun that reaches the earth. Where does it all go? Well, and it goes a long way too. It comes from 150 million kilometers away, but it is filtered. What happens is that our atmosphere happens to filter it out. It takes some of the bad things out of there. We don't need cosmic rays, gamma rays, X-rays, and especially UV radiation. UV radiation is the stuff that, if you don't wear sunglasses in bright sun, it can also make your sun blind. It's the stuff that makes your skin go brown, but too much will burn. And if you get too much sun, UV radiation, it will kill your skin cells, your body cells, and give you cancer. So this is why we need an atmosphere to protect us from some of that light energy. Some of that is not just light we see, but is in these types of rays. So 30% of the energy will come into our lower atmosphere, and then is reflected by the clouds. So something that comes down hits those white clouds and goes back, 30% of it. The rest of it keeps coming down towards the surface of the earth. So 70% reaches the earth, and that's what generates our water cycle and makes our weather. Okay? The sun is a part of what creates our weather, and also generates the water cycle, which means that it evaporates the water in the ocean and then lets the rain and snow fall. And a very small part of it, look at less than 1%, 0.23, like 0.2. That's a very small. If you put that into a fraction, that's 2 over 100. 2 over 100 parts. Or it could be 23 over 1,000. But 2 over 100 parts is used by green plants. Light is used by green plants for photosynthesis. Photosynthesis means it makes it into food. So very small of it is all they need, but we need it. What happens, though, from the sun is that humans is we create greenhouse gases. So we have our Earth, and light is coming from the sun. The sun should be a lot bigger than this. So light's coming down. Some of it's reflected back by the clouds. But we also have this area around here in our atmosphere. It's a lot smaller than this. And the gases that we generate here from burning coal and oil and all that gets trapped. It's trapped in our atmosphere. Can't get out, and it warms it up. It starts getting hotter. Okay? And over time, you'll notice that we have some very, very hot summers and very cold winters, but the average temperature of the Earth is going up all the time. Clouds, snow, and rocks, they increase the effect of the Earth. So that means that In order to reflect stuff from the Earth, we'd also have pale rocks like sand and stuff, snow. They reflect the light back. That's important in the Arctic because the Arctic is usually covered with ice. So all of that light from the sun, when it hits the Arctic Ocean, generally it gets reflected back. But if the Arctic Ocean is melting, then the water is dark. It gets absorbed by the water. It doesn't reflect back. So the Earth starts getting hotter. And you notice in the news you hear about wildfires, really bad down in California. All over the world are having problems with these big fires now. So that's an important effect. So the energy in the system is very important that we get the light. We need the light from the sun to give us warmth. We need it to give us light, but we also need to let some of it reflect back. And we need it for the plants. Plants need the light from the sun in order to make food. So your assignment, all of these things here are going to be questions you can answer from the video. First one is, what is the source of all energy for ecosystems? That's the easy answer for that. What's the source? Where does all this energy come from? The sun. So there you go. So what I want you to do is, when you print this out, you'll see that there seems to be enough room here to do this. If you don't have enough room, like in the question 5, explain what that effect is, that albedo effect, then you may have to put it on loose leaf. But right now, you might have to use loose leaf because our printer is broken, waiting for a part. If you open up your assignment on your inbox, you can see this. Just write down the answers on a piece of loose leaf and write down assignment number, Science 10, assignment 5. And when you're done, you can put it in my box, okay? And at home, they'll send it to me.